Okay, students of geometry, we're going to proceed into lesson 8 on angles formed by chords, secants, and tangents. All right, first of all, you need to know what those things are. So, a chord. A chord is a segment inside a circle that has endpoints on the circle. And you could see this in the example here. There's a purple chord. Okay? Now, chords could be small or large. Their size is not predetermined. It's not like a radius where all the radii are the same or the diameter of the circle are the same length. Chords could be big or small. The largest chord is actually a diameter. A diameter is the largest that a chord could be. So a diameter is a special kind of chord. But chords could be very small or very large, etc. Okay. A tangent is a line outside the circle that hits the circle at one point called the point of tangency, where it is a tangent, okay? So a tangent stays outside the circle and it hits the circle in one point. And in this case, the tangent is PT. It is blue. It's a line outside the circle hitting the circle at one point. And a secant is the green example up at the top, and that's also a line you could see because it has the arrows on the end, and it touches the circle in two places. So it goes inside, it's outside, goes in, and then comes out again. The tangent never goes inside, it just hits the circle once. Okay? So now, knowing those three quick definitions, you'll be able to do this matching column on your own. All right. So we're going to look at more angles and circles and the way they relate to the arcs that they intersect. Things you already know. So this we already covered. Okay? Central angle is equal to the intercepted arc. And inscribed angle is half of the arc. Okay, so we already did those two concepts in previous lessons. And now we're going to talk more about angles and arcs, but with different relationships. The first one is an angle formed by two intersecting chords. So you have one chord here and one chord here, line segments inside of the circle. They create a pair of vertical angles. Vertical angles are formed when lines intersect. So if the chords are intersecting, they're forming vertical angles. So those vertical angles we already know from our previous studies must be equal to each other. Okay, now, what you'll notice here is they are not central angles. Why? Their vertex is not at the center. So they don't equal their intercepted arcs. And they can't equal their intercepted arcs because they have to be equal to each other and their arcs are different. Okay? So they're not central angles and they're not half of their arcs. Now, how do I know they're not half of their arcs? Well, half of their arcs, the vertex would have to be on the circle. They'd have to be inscribed angles like this to be half the arc. Okay? And remember, they have to be equal, and half of 54 is not equal to half of 32. So they're not central and they're not inscribed. They're something else. Okay? And that's what this lesson is for. Now, what you're going to do is, there's something in the middle. They're in the middle of being half and equal. What? Okay, so how are we going to calculate that? Okay? What you're going to do is, and you can't be half or equal to things that are different. So what you're going to do is you're going to add the arcs. They'll be different every time. Add the arcs. And then whatever that total is, you're going to share it between the two vertical angles. Okay? So you're going to, how do you share? Two things between two, you divide by 2. So it's really the average of the two arcs. The angles are equal. Angles equal the average of the two arcs. So here's a formula. 1/2 the sum, that means to add, and when we do an average, you know you add the arcs. So the measure of angle AED marked with the X is 1/2 of the measure of angle arc AD, 54, plus arc CB, 32. So when you have an angle, you have to look at the other arc it intercepts. So you have to look at this arc and that arc. Combine them, 86, divide by 2, you get 43. And this whole problem is worked out here with an explanation for you. Okay? So this is the first thing you have to walk away from this lesson understanding. And here's 3 problems for you to practice. This one's a bit of a challenge because I'm telling you what the angle is and I'm looking for the arc. So if you use this formula and you fill in the angle, the 1/2, one arc plus the other arc, and solve it, you'll get the other arc. 1 arc plus x. Okay, this is the next situation. So that's the first thing you have to walk away understanding. Angles formed by chords. Now, we have 3 situations. Angles formed by 2 tangents, it looks like this. Angles formed by a tangent and a secant, looks like this. And angles formed by 2 secants, looks like this. Okay? Now, you need to recognize each of these cases. Look at them again and see where are the tangents, where are the secants, why is it what it is, okay? The good news is they all have the same method for finding the angle measure, okay? Angles formed outside of the circle, now you notice they're all outside the circle, okay? By the intersection of 2 tangents, 2 secants, or one of each. It's 1/2 the difference of the intercepted arcs. Okay, so now you're going to, there's some examples here worked out, but I want to just talk you through it here. What you're going to do is you want to find angle L, so you're going to do the blue arc minus the red arc divided by 2. Blue arc minus red arc divided by 2. And if you mess this up and add them, you're going to get 360. Divided by 2 is 180. And that angle could not possibly be 180. Does that make sense? So you're not adding them, you're subtracting them. Okay? This case, you're adding them. When the angle's inside, you add. When the angle's outside, you subtract. So here, we're going to do, I'll use the same colors. Blue arc minus red arc. This green piece from arc BD is not part of this problem because it's not in the angle it's not inside. So only the stuff inside is what you're dealing with. When it's 2 tangent, it deals with everything. But when you have a secant, it's kind of split up. So here's the angle we're looking for. We're not talking about this piece. Oh, I shouldn't do that. I just did, that's what we wanted to talk about. So we don't include arc AB, we don't include CD. What are we going to do? We're going to do big arc, blue, minus red, divided by 2 is the angle. Okay? So blue arc minus red arc divided by 2 is the angle. These angles are very small out here. They can't even be obtuse. I can't imagine how they could be obtuse. Can you? If this angle is greater than 180 and the segments touch a circle, I don't even know how big that circle would have to be to make that happen. So these are small angles usually. Okay, now there's no work to be done here. There's no problems for you to solve, but there are samples. So if you go slowly through these samples, and I'm not going to go through each one, you're going to see a numerical example of what to do. So to find angle ABC, here, you're going to do big arc is, what did we say? The big arc is blue. The big arc minus the small arc, right? So they're doing the big arc from A to D to C is blue, 240 here, minus arc AC, the smaller arc AC, the minor arc is 120. That is 120, and half of 120 is 60. Okay? And you're going to see this for each case. It's the same procedure. 1/2 the difference of the arcs. 1/2 the difference of the arcs. Now, instead of putting a bunch of practice problems on here, I just put a practice problems on homework 08. Okay? So I'm going to post this video for you now, so it might help you with this if it was too hard for you to understand. I hope all is well, and don't forget, send me emails or messages on Remind if you're confused or you need help. Have a great day. And we have a live class. If you're in period 8, we have a live class tomorrow. Okay? No. I'm sorry. Live class Thursday, 5/21.